If you are ready, we can start. Is it okay for you? Yes. My name is Jürgen Rudolph. I am the host of this event here today. Yes, I will talk about some digitization projects in the rail industry. And if you expect a boring monologue, yes, forget it. It won't be a monologue from my side. I have some special guests. I will introduce them in a few minutes. What are we talking about today? Is it okay? Let's take this one. The highlight of today will be the next stop in the digitization train, the precise weight measurement and balanced load. More details later on. Here we have a small agenda. First of all, we will talk about who is A1 Digital. The speaker there will be myself. For the next item, I will introduce Sandra Stein. Thanks and welcome here in this speaker's corner. She is in Fraunhofer, Austria, and on the Technical University of Vienna. And she's also the project lead of the project Physical. Later on, a little bit more about it, where we talk about the future in rail digitization, in digital twin of freight and so on. But I think Sandra is the specialist for it. Then we have here a little change. It's not in the agenda. The item with the main concerns will come a little bit later. After Sandra, we will have our next guest. This is Nicky Skujat. Hi, Nicky, welcome. He's from DXC Technology, and they are doing a little bit of software, I think, with, what did you say, 135,000 employees you have worldwide, is it right?
Exactly.
Yes, it's directly. You know a startup, yeah? Yes, a small company, and our profession is to produce data, to gain data from I think analog assets in the first step, and Nicky will tell us something what he will do with this data, and what for tools will help to bring more benefit for the customers. Then we will have the point 3 here on the agenda. What are the main concerns about digitization? I have some items here prepared, and you are welcome then to bring in your thoughts, your concerns about why did we not start in time with the digitization train, or why don't we do it up to now? And perhaps we can yes, bring you on the train that this concern will be a little bit smaller. Then the next point is we will talk about A1 Digital, what were we doing, in a short presentation of Olaf. And Olaf Lüdicke is at A1 Digital one of our excellent pre-sales consulting, and mainly also focused in connectivity and rail topics. And he will, together with Stefan Malknecht, also welcome Stefan. He's the CEO of Cargomon Systems, and he's our partner in hardware technologies, and we are providing our solution with the hardware mainly from Stefan Malknecht from Cargomon Systems, with the connectivity then from our A1 business. Yes. First of all, who is A1 Digital? We are not really. Hello. Doesn't work. Okay, now. A1 Digital is a sister company from A1. A1 is one of the largest, or is the largest Austrian telecom provider with subsidiaries in different European countries. And not enough, we are also part of América Móvil, This is a large Latin American and American telecommunication group, and A1 Digital, with its about 200 employees, is the IoT hub for this whole group. We are providing also in US and also in Latin America our IoT solutions. That's enough from A1 Digital, only to know that we are not a small startup with 5 people and existing since, I think, 2 weeks or so. Yes, yes, there are some figures. It's not really interesting. Founded in 2017 out of the A1 M2M business, and yes, we have not only the IoT solutions, the product house where I'm working. We have also a cloud product house with a pure European cloud, independent from each US Cloud Act, and we have also a cyber security product house for IT security. Yes, then I will hand over to Sandra. Do you want this micro? Yes.
No, it's fine.
Okay, thanks. The stage is yours.
Thank you very much. Great. A warm welcome from my side. Thank you all for being here. I would like you to stand up right now. Every one of you stand up. We will do a little test. I would like to test your knowledge regarding CO2. And I've prepared some questions regarding... You can stand up as well, because... Yeah. So I've got a few questions. You just keep in mind the correct answer, and if you have the correct answer, you may remain standing, and if not, please sit down, okay? No, this is not working. No, wrong side. Okay. So how many years can CO2 remain in the atmosphere until it actually ends in the natural process? Do you think it's A, B, or C? So keep your answer in mind. Who has voted for C? Okay, you may remain stand up. So all the others may sit down. Next question. How many years does CO2 have a climate effect? So it remains for 500 years in our atmosphere, but the actual climate effect CO2 has is less. It's A, B, or C. You know what? Okay. Who voted for B? Okay. You may remain. Oh, actually, you won. Okay, I didn't expect this. Okay, there are more questions, so stand up again.
A second chance here. Oh, we travel by airplane.
How many years does one tree need to absorb just 1 ton of CO2? A, B, or C? Who picked B? Okay, remain standing. It's 80 years. Here you can see 1 ton of CO2 is actually a cube of 1 meter, 8 meters, and 8 meters. And 8 meters. So, how many kilometers can you travel producing 1 ton of CO2 with the different means of transport? It's actually all of them. But here you can see here you can see the big difference between the modes of transport and 1 ton of CO2. Okay, how much meat can you eat producing 1 ton of CO2? A, B, or C? Who picked A? Great. Well done. For buying emission certificates, until the year 2030, the Austrian Rechnungshof calculated a certain amount of money that Austria would have to pay. Is it A, B, or C?
C, maybe.
C is correct. Just imagine how much projects and how much good you could do for reducing CO2 with 9.2 billions of euro. Okay, that's it. Thank you very much. Very well done. Okay, I would like to show you now how we are doing right now in producing CO2 per capita in our world. To aim or to reach the target of 2.3 tons of CO2 per capita per year, we need to do much more than we do right now. You can see how big is the difference between the single countries. In Austria, well, we are doing better, but we're not doing good. In the EU 27, the same. And of course, actually, in comparison to the whole world, it's not a lot. But if we are not doing all we can, and starting with every person in his and her world, we won't reach the target by far. So what the European Commission says is that we definitely need a fundamental transformation and not small steps, which we are doing right now. This is the European strategy for transforming the mobility, and this is what we need. And one fundamental transformation I would like to introduce to you now is the physical internet. Has anyone heard of the physical internet? Show me your hands. Okay, you, I'm hoping so. No one else. No one else knows about the physical internet. Yeah, you too? Great. You heard it. Okay. Could you explain what it is? No. Okay. I will try to explain in very simple words. Just let me come to the level we have. 25% of the CO2 emitted worldwide comes from the transport sector. So it is a lot, but we have a large lever. So we have to do something, and this is in our hands to do something, actually. And there are, of course, multiple approaches. There are managemental approaches, there are technological approaches, and these approaches all have to go hand in hand. There is not one solution. One of a large lever is actually the physical internet. The European Commission wants to bring the physical internet to life till the year 2040. And they're really doing a lot. For example, they have established the European technology platform ELIS, who is supporting the implementation of the physical internet. And actually, the physical internet is a global logistics network in which hubs and nodes are totally interconnected with transport modes and transport means. What does it mean, actually? We have our transport modes and means that are connected via IoT devices. You know exactly which goods are in which transport mean, and you know exactly the free capacity in some transport means. So what is now a very fragmented network, so that each operator, for example, each rail operator just plans its own capacities, its own devices, its own assets. This is not the case in the physical internet anymore. Assets are shared. Information about free capacity is shared. The people are going to use in a shared and common way all possible transport means and modes and try to integrate on a not intermodal but synchromodal way, that's, let's say, in real time using the best possible way for transporting goods. So here we've got the interconnectivity and interoperability. So here we need IoT devices to know about the status and the location, etc. of the goods. We share and optimize assets such as cargo space, in nodes, for example, we have shared warehouses, etc. And at the same time, we have IoT devices as enabler for this interconnectivity. Here you can see some figures what the physical internet can have for which impact the physical internet can have actually. And these figures, if really the physical internet comes to life are real and they are scientifically proven. Here you can see some assets that enable the physical internet right now. These are not new assets, actually. We all know them, have them, they are already implemented, but the interconnection of these IoT assets makes the physical internet at the end implementable and livable. And I would like to talk about one aspect today. It's the weighing of assets, which is an IoT device as well. The weighing of assets is a part of our common research project, InnoTrans Digital is part of. And we have got a pilot project in which we built a new transport container for wood. Obviously, in Austria, we have a lot of wood. And we try to implement a collaborative wood transport. Collaborative wood transport does mean that different farmers put their wood into the container, but we have to know which farmer put how much wood into the container, so that a collaborative transport and a fair benefit sharing of the transport is possible. Therefore, we developed a construction of a new container, and InnoTrans Digital and Cargomon as well are now developing sensors for weighing the container. We are commonly doing this research and trying to find the best possible solution for this. And afterwards, all the data that we gather is going into A1 Digital's exascale. Out of the exascale, we build our digital twin of the transport chain so that we can, at the end of the day, optimize the whole transport chain for the wood transport. So here you can see the impact of the weighing technology. We actually see a significant reduction in CO2 because we have we have a higher utilization rate, a reduction of training processes, and a reduction of logistic costs, actually. So we are here to do a scientific proof that this is actually working. And what A1 Digital is really great at is supporting our research and putting the heads together for finding the very best solution for this innovative container and for the digital twin that comes at the end. Yeah. The physical internet is quite complex. I just showed you one single slice of the whole of the whole concept. Actually, it is a paradigm shift. People have to think completely different, but it's the only way to change something, to do actually something against the climate change. So I leave you here with that statement more than 100 years ago, and whenever you've got a question, please, at the end, we will have a discussion. Please feel free to ask. Thank you.
Thank you, Sandra. Thanks a lot. Thank you for your applause. Yes, the main reason why I invited Sandra is because it's very interesting. And the second reason was that we want also to show that we are not only working on the actual technical facilities, what we can offer. We are also working with A1 Digital and with research institutions for the future of a better and CO2 emission reduced future. So, the next of our speakers, Nikki, may I ask you to come to the floor here? Thanks a lot. Give him a small applause. Thank you. Yes.
Okay, then. Thank you. Also, warm welcome from my side. At begin, he said that DXC is not known in the world. This is a little bit true. We are a 135,000 employee IT company, or we deliver IT services, let me say, in all industries. But I'm from a special industry, from rail and transit solutions. I'm the leader of a small team in Germany. We develop with around about 100 people IT solutions for railway undertaking and factory railroad companies. Just now, you see, this is the big highlights from DXC. We are a global company. Me and my team, we operate more or less in the European world, actually. Maybe later in the global world, we will see. But in the European world, I think we have a lot of things to do. Actually, we work with different clients together. We are using our software, what we develop. The software or the clients are, you can see it here, larger railway undertaking companies, also companies from larger industries like chemical industry, BASF, Evonik, or voestalpine in Austria, or ArcelorMittal, large steel companies. It means companies with with a big amount of railroad transports. And for example, BASF, we have in the largest location. I don't know if everybody knows that in the largest location in Ludwigshafen, we have 200-kilometer tracks. We operate with 45 shunting locomotives and shunt every day between 4,000 and 6,000 rail cars, from the inbound trains to the loading, unloading places, and back to the outbound trains. The solution, what we develop, has a lot of components. We have a lot of modules. This is normally a slide where I can talk around about 8 hours or something like that. So I try to speed up a little bit. So we have in the solution modules for the financial things, the order management. So we can create offers, contracts, orders, purchase side, sales side, so that our clients have the cost under control. So we have the revenue and the margin and all the things in the system. We have capacity management. For example, for Switzerland, in the single wagon transport for SBB, all the single wagons will be transported, will be booked on several trains with help of the capacity management. We have resource planning, so we can plan long-term, short-term. The trains, we can plan fleet. It means the locomotives or the rail cars. We can plan the crew, all the people, what are needed for preparation a train, or if a train has arrived, a train check after the arrival. We have the track access in the system to the rail infrastructure providers, and we plan also the wagon rotations. On operations management, like I said, we have two different types of clients. We have the wagon load transport clients with single wagon transports, full train transports. We have the intermodal clients with the container transports or small bodies, trailers, all the things what you can put on a rail car. We have the yard management, and we have the solution for industry railroad companies. At the end of the operational process, we have the accounting, so we can calculate the costs on the sales side, on purchase side. We can checking incoming invoices, generate invoices, have the cost accounting in the system, and have also a couple of sub-modules like monitoring, track and trace. And I think this is one of the most important things where sensors and devices can help us in track and trace and also in fleet management. So, but if we find out with sensors that something has happened on a rail car, we can, and we get the information in the system, we have the possibility to react, and we have the possibility to give warnings to the planners and dispatchers and all the people what are working in a railroad company or in a shunting company. So this is the big picture of the solution. We have also some master data and also nice optimization for optimization of round trips of the locomotives or for staff, or optimize the booking from the rail cars in a train or from a container on a rail car and things like that. So the topic from today is what is the synergy between diagnostic tools and RCMS, or the solution what we develop. We have, let me say, from the software perspective, we have two different worlds. We have on one side we have the rail infrastructure, where we can get data from maybe video portals or other sensors, and we have the possibility to get the information from the rail car or from the container, from let me say from a digital IoT platform, maybe like the platform from A1 Digital. What can we do with the data in the system? So, and I split it here a little bit off in the two worlds. The data for the from the local railway system, or from local railway systems. Yes, we can here detect with video detection wagon sequences. We can get wagon data, like the dangerous goods information, what are printed on the rail car. We can see damages if the brake is broken, or other damages. We can see load information, so we can use the RED data, or we get also scaling information. If a scale is in the network, we have this information. And also, this is a little bit a funny thing. We have one client, he is interested on the sprayed and nice colored rail cars. I think in the rail cargo world, it's not so an important thing. It's more in the passenger transport, because if you have a passenger train with a lot of spraying, it looks not so nice, and sometimes the passenger are also not happy about the nice colored, or not the nice colored rail cars. From the devices what are placed on the rail cars, or on the containers. Here we have also, or we can have also, a couple of information about brake temperatures, or bearing, or something like that. We can get information about axle loads, and I think this is a good thing to have it on the information on such a device, because if the wagon is overloaded and the axle load is too high, and the sensors in the infrastructure detect the axle load, it's too late, because the train is running. So the thing what you can do is stop the train in the next station, and try to put goods off the wagon. So, but if you have the sensors on the wagon, and you have the exact information about the axle load or the gross weight, then you can save a lot of money. You can save a lot of work. Save a lot of CO2 because you doesn't have additional shuntings and trains and things like that. And it brings our clients to the possibility to operate better. And I think this is in the rail world one of the major things, because we have the model split between the truck transport and the rail transport, and everybody is crying if the rail transport is too expensive. We can save also money if we detect such things as soon as possible. And also some other things like damages on wheels or damages in the infrastructure. So, but here we have a very interesting thing from my point of view. Who is the owner of the data? Because our clients are the railway undertaking companies. So if we get the information about the broken track, it's nice for the railway undertaking company, but the information has to come over to the rail infrastructure company. And I think we have here also in the European rail world a lot of possibility to work with such data, what the devices can provide. So thank you.
Thank you, Nikki. Thanks a lot. Nikki mentioned that way measurement is necessary. We will later on have a nice presentation what we will do in case of weight measurement, and also these other data we gain from our devices and from other devices are very important to have additional use cases also in the rail business. We want to smart up your freight wagons is our next point. And let me come to Olaf and Stefan in accompanying him, telling first what we are doing at A1 Digital, and in the next step also the presentation of the way measurement. Thanks.
Thank you, Jürgen. We got an interesting presentation from Nikki about what his software can do. And as he mentioned, outside of the software world, there is a real world, and you need to collect the data. And how does it work? And here you can see actually how the system behind which delivers the data to the software works. And let me start it from the back. So here you see, like it's called enterprise system. It's a software like DXC, and usually such kind of software is connected to our IoT platform. What does that mean? That is a system where all the payload, all the information of the sensors on the outside are stored, and additionally all these devices which are installed on the wagons and are somewhere out on the rail tracks are managed, like software updates, firmware upgrades, security bug fixes, and so on. There's the next step. Somehow these informations must come into our platform. And how does that work? Usually it's used mobile connectivity, the same networks as you are using in your smartphones, meaning there's a kind of a SIM card in all the devices. And here's then the device itself, and this is where Stefan comes into place. Stefan's company Cargoman is our partner for the hardware, and these boxes are installed on each single freight wagon and have a lot of sensors on board. And the main feature, or one of the key benefits of these devices are, and this is why we are using them, is there are no cables at all. It's all wireless. And additionally, they are energy self-sufficient. That means there's a battery inside, or sometimes there's a solar panel. And at least the battery lifetime is the typical maintenance cycle of such a wagon, because you don't want to bring the wagon in again just to change the battery of such a small device on such a big freight wagon. Wrong direction. So, and now Stefan, if you could come over. This is like how it looks like. It's a quite high accuracy system which can measure the weight and the load of such a wagon. He's the expert. That's why I would like to be a little interactive. So my first question to you, Stefan, what was the main motivation to develop such a system, such a sensor?
Well, the main motivation was the requirement from the rail industry, because we had already a system in place before, and it was about maybe 5-6% accurate. And that system was measuring the compression on the spring, on the bogies, on the chassis to the bogie, the difference in height. And that was about 5 to 6%. But that was not enough, because, like railway, when it's overloaded, they get stopped at the border to Austria, for instance. In Germany, they don't have so many of them, but in Austria, it's critical. So they take out the wagon, costs a lot of money, and 6% is the absolute limit. So there was a new requirement coming that we need something. It would be perfect if it would be 1% below, and that's very hard to achieve. But 2% and around 2% is also a good achievement. And so we decided to think about a new sensor in a research project, and this runs on strain gauge sensor. So what is a strain gauge sensor? It's a very tiny sensor. It's like a post stamp. It looks like a post stamp, and it's thin like paper. And you glue it on top of a steel plate, and this sensor element with some electronics is welded, like here you see the whole sensor system is welded on the bogie, and it measures tiny changes in the compression of the in the bending of the bogie itself, and it's very sensitive. It can measure even kilograms.
Thank you. You already answered my next question. How do you achieve this high accuracy? And the other question that comes to mind is, how does the installation process work? Do you have a large number of employees going to the customers and installing these sensors on the wagons? How does that work?
That's quite straightforward, because welding is a process every repair shop or support shop is able to do, and you just need to weld 270 millimeter lines of weld spots on a bogie, and that's no problem, and our customer does it for us.
Okay, and what are, out of your experience, the main use cases from your customers why they're asking for such weight measurement systems?
Okay, talking about the use cases, one main use case is overload detection. A second main use case is measuring the exact load while loading. So the customer loading, for instance, timber in the middle of the wooden place, wants to know, can I load another few trees, or do I have to stop now? So getting to 100% limit, very close to 100%, that's one goal, and there you need real-time information. So it cannot rely on information from the cloud, it must see the information right in front of the wagon. And there is a third use case, which is used just for replacing the normal weighting.
And how does that work in detail? So that you, it's nice to have it in the cloud, sure. But how does the loader who's loading like the wood onto the freight wagon the actually weight? How does that work?
Maybe you skip to the next slide and there is a picture. Yeah, exactly. What else than using an app nowadays? Everyone has his cell phone in the pocket, and instead of mounting displays on the wagon, we let the loader just use an app where he can see the wagon surrounding. He can automatically see, without connecting, via Bluetooth low energy beacons, the real-time weight in real time. And that's the goal. And if it's overloaded, it knows the maximum load for the certain track and the next trip, and then it can immediately show in red or in green if the wagon is evenly loaded, unevenly loaded, or overloaded at all. So that's why we also use 4 sensors and not just 1 sensor. It's more reliable, it's more precise, and you can measure even uneven loading in front, back bogie and left, right of the wagon.
Okay, thank you. That's a good insight. So, and as you can see, all these systems cannot work standalone. You need these accurate sensors. You need a system transmitting the actually sensor values to our platform. And it's not only transmitting the sensor values. There's a quite complex algorithm behind to really calculate the weight in tons, not some strange numbers. And then you need software like these ones of Niki and DXS to really process these things. And now I hand over to Jürgen again about the general questions and concerns which might come up regarding digitalization. And you're very welcome to raise questions. Also, critical questions are very, very welcome.
Thank you, Olaf. Thank you, Stefan. I think it was really impressive, and when I watch all these items, all these possibilities we have still, which are still existing in the world, I'm wondering why not every wagon owner has completely equipped his freight car with this digital equipment, because. And this is not one of the concerns I posted here on the slides. Is the first one is it's too expensive, and my answer then is always, if you don't have the money for buying digital equipment, you have in the background to have more money, a lot of more money, because the return on investment with the optimized digitization topics is really in a overseeable time. This is my point of view, and Is there anyone who can confirm it or speak against it? You want to say something?
If you would share some numbers of the costs, it would be maybe easier to calculate the ROI.
Yes, I'm with you, but it's not globally to answer. Yes, we can talk to the customer. We can talk to his situation. It's not a product out of the shelf. Yes, we have components out of the shelf. Yeah? But the whole system is not only one sensor for, let me say a number for 700 euro with a connectivity for 20 euro a month, and that's it. No, we need a whole system. We need the system like Olaf presented before. We need the right hardware. We have to select together with our customer the right hardware, which is optimized for his use cases, for his situation. We have the connectivity depends. It's only in Niederösterreich, in Lower Austria. It's only here in Berlin, or is it worldwide? There are some differences. We have an IoT platform as a hub to have a backwards channel for the devices. This can be in a normal cloud, in the pure European cloud. There are also differences, and we have also data analysts behind to make more out of this data. We have the connectivity to the existing systems, and there is a lot of items to be aware of. In the field of digitization. So yes, it costs money, but it brings also money. And not only money, it helps to be competitive against other rail operators and also to be competitive against road transports. What's one of there's no electric power on board. I think with our solution, we said with the normal battery device, we have a guaranteed battery lifetime of 6 years. And I've seen Martin here. Can you confirm that this is not only in the PowerPoint? Do we have experience with these devices?
So indeed, I was one of the first customer representatives. So that was, of course, one challenge. We've learned that the hardware works out perfectly, that this is not an issue at all. Perhaps to answer the one point that you had before, I think also calculating the ROI is not the issue. So given the asset costs that we have in our industry, we're not talking about significant cost. The difficulty from my perspective is that the return that you can gain, you will gain if and only if you adapt your operations. So it's not a solution that you purchase and you start to save money the next day, but you get insight, and then you need to take the insight into daily operation in order to gain the return. And this is a very traditional industry that we are in. So convincing a traditional customer to change the way of operation is, I guess, the biggest obstacle to the return.
That means, you mean the customer has to be grown up enough in the digitization process to be ready for the digitization?
Yes, and I mean, it's also a question of accuracy and the trust in accuracy, and I think proving the accuracy of your data is rather straightforward. But then the next discussion immediately starts with, but what is the implication out of that? So if I expect a flat spot on a tire, for example, will I take this wagon immediately out of operation, which is at cost? Of course, the cost is higher of keeping it in operation, but what about false positives? So this is especially if you're far away from those processes, these discussions come up immediately, and that is something that you can only tackle with operational excellence, I guess.
But one thing has to be quite clear. We cannot recommend exact doings then. We can send data, there's something wrong, but the decision has to be at the customer. That's right. Yes. Thank you. Okay, the no electricity can also be via a solar device up to 10 years, and we decided for this battery with 6 years guaranteed lifetime, because the normal service intervals are 6 years, and the cheapest way is to change at the next service the device, and everything will go on like you are common with it. Then the next one, the environment is too rough. I think you can have a look and feel at our booth at the Advantage Austria in Halle 21. Here we can demonstrate this. I think yes, you can destroy it, but only with significant power. Time-consuming mounting on the wagon. I think we did a study in former times, and I think I was involved with Martin together, because in my former position I was part of the innovation team at Rail Cargo Austria. And we ask our workshops there, what do you assume will be necessary for mounting such a device, and to marry it with the wagon ID and within the workshop tool. And it came back, I think 30 minutes, they say it, approximately. And finally, we created a suitcase with all necessary material for mounting, for provisioning, for waking up the device and so on. And we reduced this time for about 7 minutes, I think. 6 minutes? Okay, 6 minutes. Okay, we saved 24 minutes for about 12,000 freight cars. It's nice to figure out how many years we saved with it, but yes, everything is possible, and together with our customer we are trying to find out the best possible solution. Then it's a too complex integration in existing systems. Yes, it is, and most of the customers have existing system, not with modern global tools. They have mostly out of Excel lists, some self-made whatever tools, and nevertheless, we try to do the best integration in the existing systems, but this is also a point why I cannot say what will it cost, because I do not know the existing systems of the customer, and sometimes it's quite easy to integrate it in the existing systems, and sometimes it's really difficult. Yes, next one. How to connect additional sensors. I think some of the solutions on the market have a connection to sensors via wire. Our philosophy is to have no wire on board. I think Olaf mentioned it before. Everything we can add with additional sensors will be connected via Bluetooth Low Energy, and the data from the sensor will be transmitted by the main basic device to the IoT platform. So no wire, and there's also no risk for damage by broken wires. Does an acceleration sensor make sense? The main reason why we integrated the acceleration sensor was the improper loading of especially iron waste loaders, and it's not possible to detect damages, but to have an indication for some hard shocks in the vertical direction at this geolocation. And I think only the information that the customer is monitoring these shocks at this geolocation to this time have reduced the real damages for, I think, between 10 and 20%. Is it correct? Yes. he said yes, it's in this direction. And I heard also from customers, it's not necessary to have these sensors because we will tell them that we will monitor it, but it doesn't really make sense. Yes, we will monitor it, and these damages reduced, these information to monitor the shocks reduced really the damages, and this reduced also a lot of costs in the workshops. Have you any other ideas which concerns can be situated by why we will not equip all freight cars with digital equipment? You're free. You can use this microphone here, or I'll bring it to you. Do you have any additional idea? What can we here add? This was my thoughts. Anyone? No one? Yes.
We already equipped some of our wagons with devices, of course not A1 digital devices, other ones. Is it possible to mix the devices on that platform?
Yes, it is possible to mix. Hello? Yes, it's possible to mix it, but it's not so easy. And there we are on the point what I think Nikki mentioned. Who is the owner of the data? If we will have foreign wagons with other devices, it's mostly not a technical question to connect them and to bring them together on the same platform. It's mostly legal questions why it will not work. Any other question? And let's open the question round, not only for the concerns. Are there any questions from your side, especially to our guests here, to the future projects, to the software item or the weigh measurement? And what I can offer you is we have a small model at our booth in Hall 21. From Cargomon Systems, where you can have a vision how it could work with the app from Cargomon to see originally in time the difference of different loadings. This is an invitation to our booth there at the Advantage Austria corner. Any questions from you? Yes, Martin.
So I'm just curious, thank you very much for the presentation also on the physical internet. We were discussing years ago with only the first Cargomon box. The data that you would have is the motion sensor, the shock sensor, the temperature sensor. So we were just considering with this very, very, very limited number of data points per, 30 minutes or 12 hours. We have seen use cases like you would have 20,000 weather stations moving around Europe and so on. Do you have some vision on where you can else use all the data and which benefits can be set on a higher leverage if you connect it?
Okay. Yes, of course. Just imagine disruptions in the transport chain, just as we had when it came to the large rainfalls and the high waters. If, for example, deviations are necessary because the railway is not passable anymore, we could decide in real time, for example, okay, we load these and those freight items onto, because they are time critical, onto road, and the rest, for example, can stay on the track because it's not really critical for a time slot in the port, for example. The most we know about the freight we are transporting doesn't matter exactly which data, but the most we know, the better we can optimize, especially when it comes, for example, to such disruptions in the supply chain. But also optimization in any way would be great when it comes, for example, to collaboration of operators. Normally, operators just optimize their customers, their network, but if they exchange data about their goods, well, more or less anonymous, we can achieve a lot of synergies on a horizontal collaboration level. And these are proven as well. So the data can be, if you can demonstrate how much effect the data optimization has on the whole supply chain, I think operators can be pursued to, for example, collaborate. Because at the moment there is no collaboration, actually, no vertical collaboration in the supply chain.
Thank you, Sandra. Are there any additional questions? Thank you. Just one question. Yes, sure. Sure.
You mentioned before that the technical integration of different devices is not the problem. You mentioned more the legally topic. Is this in your project already covered for the future? Because this has to be solved.
Absolutely. Well, in our project, we have a very small amount for legal advice. But I think we, as a flagship project, cannot solve those questions. This has to be on the European Union level, because there are a lot of legal questions. Of course, we in the project cannot solve it.
Okay, thank you. If there are no additional questions,
just a quick comment about this. This is like a general problem in IoT solutions. If you're, for example, renting out machines and you are equipping your machines with sensors and you're gathering information about the machine, who is the owner of these data? Is it the owner of the machine, or is it the operator of the machine? And this sometimes really is a question of legal, let's say, challenges, which sometimes even stop projects, because in the end nobody is going to take the risk that he's getting sued for misuse of data.
Is it answered? Is it answered for you? Yes, thanks a lot. Yes, finally, let us be aware that we have railways now for about 200 years. And I think 3 years, absolutely analog in the freight transport. And digitization has started some years ago, and I think it's really necessary to force it and to bring it to more competitiveness, especially compared with the road transport. And I think there are also our politicians are really forced to do regulations easier in the freight transport to make it competitive and to save CO2 emissions. I think, yes, these are my final words for it, and please visit us also in Halle 21A, 21A, booth 350. We can have further discussions, and if you will share this event here with your colleagues or whatever, you can reach us out, and we will then in a few days we will send you a link where you can show this event here. Thanks a lot for all. Thanks a lot for our guests here on the podium. Thanks a lot for your attention. Have a great InnoTrans. See you at our booth. I would appreciate it. Thanks a lot.